In this problem, it says assume the cost of an extended warranty is a 100,000-mile warranty for a particular SUV. And it follows the normal distribution with a mean of 1,200 and a standard deviation of 100,000. And so what we're doing here is determine the interval of warranty costs from various companies that are one standard deviation around the mean. So one standard deviation around the mean would look like this. So here is going to be our interval. All right, so we're going to take the mean and we're going to add 1 times the standard deviation, and we're going to take the mean and subtract 1 minus the standard deviation. Well, here the mean is 1,200 and the standard deviation is 100. So down here, here's 1,200. So one standard deviation above it would be mean plus 1 times 100. So that's going to be 1,300. So right here would be 1,300. Now let's do the interval below the mean. So now we're going to do 1,200 minus 1 times 100. Well, that's going to be 1,100. So our interval for one standard deviation of the mean is between 1,100 and 1,300. And the empirical rule says that 68% of the values would fall between that interval of 1,100 to 1,300. Okay, for the next one, we're going to do 2 standard deviations from the mean. So we're going to do, this is still going to be 1,200 right here. And to get this one, we're going to do 1,200 plus 2 times the standard deviation, which is 100. So 2 times 100 is 200. So the upper interval is 1,400. Now we're going to do 1,200 minus 2 times 100. So that would be 1,200 minus 200, which is 1,000. So the interval, and the way you write the interval is in interval notation, which looks like this. And the empirical rule says that 95% of our values are going to fall within 2 standard deviations of the mean. Remember, 68% of the values are going to fall within 1 standard deviation of the mean. Okay, so our interval is 1,000 to 1,400. The last one is 3. And almost all, 99.7% of the data will fall within 3 standard deviations of the mean. Let's see what that's going to be for our problem. 1,200 plus 3 times 100. So that's going to be 1,500. And over here, we're going to do 1,200 minus 3 times 100. So that's going to be 900. So our range is going to be from 900 to 1,500. Okay, it says an extended 100,000-mile warranty for this type of vehicle, if we wanted to extend the warranty, is advertised at $1,600. Based on the previous results, what conclusion can you make? Well, let's look at where 1,600 would be. We know that 1,500 is 3 standard deviations of the mean. So 1,600 is going to be greater than 3 standard deviations of the mean. So 99.7% fall within 3, so this is 0.3%. That means it's way out here. And so the 1,600 is definitely much higher than average due to the fact that it is more than 3 standard deviations above the mean. Okay, question 11. We have an interval here. I'm not going to go through all of this, but it asks in part D. The price intervals in part B and C are equal intervals. In other words, 400 and 500, that's an interval of 100. 900 and 1,000 is an interval of 100. Okay? But why are the probabilities so different? Do you notice here that the probability of B happening is about 2%, and the probability of C happening is greater, and because it's 14%? Why is that so? They're only the interval, they're both $100 spread, but look at your mean up here. Your mean is 780. So 900 to 1,000 is closer to your mean. Remember, I mentioned this in a previous video, and I want to go back and emphasize this. When I first introduced normal distributions, let me see if I can find it. Values near the mean, where the curve is the tallest, have a higher likelihood of occurring, which means if it's closer to the mean, it has a higher probability of occurring. So since 900 to 1,000 is closer to 780 than 400 to 500, then the probability is going to be higher. So the interval 900 to 1,000 is closer to the mean than the interval of 405 to 500. That is why the probability is so different. And then this last part, suppose a couple is shopping on the electronic store's website for a new 42-inch television with a budget of $730. There are 14 42-inch televisions on the site. How many televisions are within their budget? Okay, so we have a budget of $730 and the average is $780. And our standard deviation is 150. So we need to see, first of all, what is the probability of the TV being 730 or less. So I'm going to go into my Excel, and I'm just going to use the one where I can put in X without having to get the Z-score first to save time. So here X is 730 because that's my budget. And the mean, I believe, is 780. Okay. The standard deviation, I believe, was 150. And it's cumulative because we want to know the probability up to that dollar amount. So I get 0.36944. And that is 36% of the TVs will be within my budget. Well, how many TVs are we looking at? 14. So we're going to do this number, 36% of 14. So it looks like you can't really, you're going to round down here. So you're going to say there are 5 televisions within that range. Okay, question number 12, you're just going to use your formula that we used earlier in this video. I'm trying to find where we did. Okay, right here. This is what you're going to do. The mean plus 1 times the standard deviation, the mean minus 1 times the standard deviation. You're going to do that for 2 standard deviations and for 3 standard deviations to get your intervals there. And I believe that completes completes section 6.2. Let me know if you have any questions.